Grid Singularity's D3A is a tool that can be used to simulate energy exchanges and ultimately deploy them to enable peer-to-peer trading in communities and cities. In this tutorial, I'll show how users can log in to d3a.io in order to run simulations and to also learn about the general features that we have at Grid Singularity. So logging in on the home page is where we put all of the tutorials that we have for different features in D3A. And then you can start building a simulation inside a project. So I've added a project here and I'll start a new simulation. On my settings page, I can click how long I want the simulation to run. So let's add a couple more days here. I can also choose the market type, which you can read more about on our wiki. And then I can start modeling the grid. So in order to model a grid in D3A, there are two components. One is the market and one is the different devices or energy assets that can be added. So I can start adding markets and devices here, but to save some time, I'll add a pre-configured simulation from my library. So now I have a community with 5 homes in it. And so each of these homes has load and PV energy assets inside of them. And these energy assets are controlled by agents which place bids and offers into each of the markets. So by setting up this simulation, my 5 homes can trade with each other inside the community market, and then they can also buy energy from the market maker, which sells at 30 cents per kilowatt hour. And the market maker is similar to, could be your local utility. So maybe the local utility is selling at 30 cents and has a feed-in tariff at 12 cents. So as I go into my community, we've added a new feature where I can add a geotag for each device or market. So I'll show how we can add a location in this community. So by clicking on location, it opens up the map feature. And let's type in Potsdam, city near Berlin, where we're located. So I can zoom in on the map here and save my house at this address. So now my load and my PV are saved inside my house at this address in Potsdam. And so we can see the community immediately creates an area around my home, and then this goes up to the market level. So let's set some addresses for the other homes. So if I'm simulating my local community, most of my homes are probably on the same street. So I can just click to add this home further down the street. And then I can keep adding my homes here. And so the upper community area expands to include all of the homes in my community. So let's add this one maybe a little bit further away. And so this way I can actually visualize all of my homes and how it would look in a real world use case. And this especially comes into handy once we start looking at zip codes and who the grid operators are that operate over certain areas in the grid in terms of how different grid participants should participate in this future energy exchange. So now the next step is to run my simulation. So to run my simulation, I go to the results page and you just click run. And while the simulation is running, there's a timeline here that will start to show the status. And then we show the results for every single market or device in my grid configuration. So I can click on each individual load to see the behavior of that load. And we can see the profile, how much energy the load bought, and then what the price was that it paid. And the same happens in the home market. Then I can see the final bills for, or what the PV profit was versus what the load paid inside this home, and then what the cumulative is. So let's go back to the highest area, and now we can see that the simulation is already in its third day. So now I want to know how my results might change if I add more devices to my simulation. So I can add a storage to my simulation, and these parameters are just related to the strategy of the storage. And so this can be configured by the user, or in our hackathon setups, we have other users that can register the device to the device and then make bids and offers on the device's behalf based off of any algorithm that they're coming up with. So then I can add a location to where my storage is in the community just by clicking on the map. And now my storage has been added as an event. So going back to the results page, I can already click on any events in the timeline, and then I can see the profile of the storage. So it just got connected to the grid in day 5 or 6 here, and I can see the state of charge, how it's buying and selling energy, and then the price that it's paying. So let's go back to the community view, which is probably the most interesting for this use case because we want to see different parameters about the community. What is the self-sufficiency? What is the self-consumption? And what is the impact of adding energy storage to this community in order to understand what the metrics are and the impacts that this has on maybe any grid congestion or the prices that the community pays for their energy. So here I can see the energy bills for the community, how much each home is paying, and the profit that the storage is making. And then we have the energy trade profile for the community. And in order to look at what the peaks are, I need to filter out the external trades. So that's what the peak analysis tool does. So it filters out the trades that are going from the community to the upper part of the grid, to the utility basically. So I can see after I added the energy storage, there is more self-consumption inside the community. And so this excess PV energy is being consumed by the energy storage and then discharged in order to benefit the community when it needs energy. We have many more graphs, and these can actually, the charts visibility can be controlled in the side panel here. And this graph in particular is very interesting. It shows all the bids, offers, and trades in this community market. So it helps me see these light blue dots are all offers. So these are all the offers coming into the market, and they're starting at a high price and going to a lower price. And then the bids are doing the opposite. They're starting at a low price and increasing their price to be higher until they can actually match with an offer. And so that's what the dark blue dots are here. Those are marking all the trades that happened during that time and which agent traded with which. So we can see the PV3 sold to the storage here during this time. Great, so there's many more, so much data here and many more results that can be analyzed, especially looking through the entire grid hierarchy. The last thing I'll show is the global map, and this shows all of the simulations that have been created inside D3A that other users are running. So we can see the simulations that are set up in different places around the world. So that is the broad overview of what is in version 0.8. We also have a library that allows you to save grid configurations and then add them to your simulation as chunks, so you don't have to configure everything by hand. And then we also have collaborations, and this is what we used for our hackathon in July and what we'll use in November. And so the only difference here is that there is a registry and a scoreboard. So when the user, when we create a grid simulation, different users, different hacker teams can actually register for the different devices and train on their behalf. Great. Well, that is the summary of version 8. Please, let us know if you have any suggestions or questions.